Hello students, how are you all? I hope that you all are good. As we know, the series of motion in a straight line is going on and we have successfully finished the 4 lectures. So in a previous lecture that we have discussed about average acceleration as well as instantaneous acceleration. And we have discussed some examples how to find the acceleration when they are given velocity equation. Okay, average acceleration as well as instantaneous acceleration. Also, we have find that whenever the displacement equation is given in the form of vector, then how to find the average and the instantaneous accelerations as well as instantaneous velocity. At the end of the session, we have discussed some integration formulas. So how to find the displacement when they are given velocity equation and how to find the velocity when they are given acceleration equation and all these things that we have discussed in a previous session, right? So in this session that we are going to discuss about a graphical section. Okay, so how to find the velocity when they are given a displacement versus time graph, how to find the acceleration when they are given velocity versus time graph, and how to find the displacement when they are given velocity versus time graph, and how to find the change in velocity when they are given acceleration versus time graph. And all these things that we are going to discuss in today's session. Okay. So my name is Rakesh. Welcome to our beautiful physics channel, Rakesh Sir Physics. Shall we start the session? Right. So what is the chapter going on? Motion in a straight line. Motion in a straight line. What is the session number or class number? 05. What is the topic today? What is the topic today? Graphical section. Graphical section. Right. So the first topic I am going to discuss about of velocity or instantaneous velocity. Instantaneous velocity. What is instantaneous velocity? The rate of change of displacement. So that is what? ds by dt. V instantaneous is equals to what? ds by dt. Already I told you that what is ds by dt? What is the meaning of ds by dt? So ds by dt is nothing but what? The slope of graph of the slope of graph of S versus T. S versus T gives a instantaneous velocity. Already I told you that ma. Okay, slope, basic mathematics used in physics. Slope concept. Okay, lecture number 3, I think. Basic mathematics used in physics 03. In that concept, in that lecture, I am completely discussed about slope only. So where is the slope? Here is the slope. I'm completely discussed about the slope only. So what is slope? How to measure the slope? Okay. So what is tan theta? Where the slope is positive, where the slope is negative, and where the slope is constant. Okay. All these things that I am discussed in that lecture. Watch that lecture once. After that, you listen this class. You can understand clearly. Is it clear? Right. So what is the meaning of ds by dt? The slope of graph of s versus t gives instantaneous velocity. Is it clear? Right. So how to find the slope? The formula for slope. Already I told you. Slope can be given by tan theta. Tan theta is equals to what? Displacement by time. So what is the graph of displacement versus time gives? Instantaneous velocity. So slope is equals to tan theta is equals to instantaneous velocity or velocity, whatever it is. Okay. So this is the formula for instantaneous velocity. Now, what is theta? How to measure an angle theta? I told you that always take an angle theta from positive x-axis towards slope. Okay, always take an angle theta from positive x-axis towards the slope. So wait, have a look. Analyze the following slopes. Analyze the following slopes. So they are given slopes like this. Right? This is our x-axis and this is what y-axis. Okay, so the line is crossed. Just try to draw straight line. Okay, so this is what y-axis and this is x-axis. So along x-axis, I'm taking a time and t. Time is what? T is the time. So along y-axis, I'm taking the displacement. And what is displacement? This is the displacement. And they are given the slopes like this. So this is the first slope, and this is the second slope. Right. This is the second slope. This is the third, fourth. So this is the fourth one, and the fifth graph is like this. Fifth slope is like this. This is the fifth slope. First slope, second slope, third slope, fourth slope, and the fifth slope. And we have to analyze the slopes. So what is the instantaneous velocity at a first slope? What is the instantaneous velocity at a second slope, third, fourth, fifth, all these things that we are analyze. Okay, right. The first slope, how they are given? The first slope is like this. So draw the straight lines. X and y axis are straight lines. Okay, so this is x axis and this is what y-axis. This is origin O. This is the first slope. They are given like this. Are you getting? So this is the first slope. I'm taking the first slope. Okay. So one thing is clear that so this is the graph of time versus displacement versus time graph. Okay. The slope of graph of s versus t gives what? Instantaneous velocity. That means this slope gives what? Instantaneous velocity. How to find the instantaneous velocity? By taking an angle theta. So we have the formula. Slope is equals to tan theta is equals to what? Displacement by time, which is equals to what? Instantaneous velocity. So instantaneous velocity is depends upon what? An angle theta. How to measure an angle theta? So always take an angle theta from positive x-axis towards the slope. Have a look. This is the positive x-axis. So with respect to this positive x-axis, the slope is parallel. Have a look. This slope is parallel to this positive x-axis. Then what is the angle between them? 0 degrees, because they are parallel to each other. So from the graph, it is clear that an angle theta is equals to how much? 0 degrees. If angle theta is equals to 0, then tan theta is equals to tan 0 degrees is equals to how much? Tan 0. We will get 0. If tan theta is equals to 0, then 0 is equals to what? Instantaneous velocity. Therefore, velocity or instantaneous velocity, whatever it is now. So therefore, instantaneous velocity is equals to how much? 0. Are you getting? This slope is parallel to positive x-axis and the angle between them is how much? 0 degrees. If theta is equals to 0, then tan theta is equals to 0. If tan theta is equals to 0, then how much? It gives a value 0. If this is equals to 0, then instantaneous velocity is also 0. Velocity of the object is 0. Then we can say that the object is at a rest position. The object is at a rest position because the velocity of the object is how much? 0. Is it clear? Right. So see the second graph or see the second slope. So what is the second slope they are given? This is the time and this is displacement, and the second slope is for moving from origin. Okay, like this. From the origin, the second slope is like this. Right. Now we have to find what? an angle theta. How to find an angle theta? Always take an angle theta from positive x-axis towards the slope. So this is an angle theta. I'm just taking this one. At what angle this point is there from positive x-axis? At an angle theta. Again I'm taking out one more point on the slope. Okay, so from positive x-axis, what is this angle? Have a look. If this is theta, then this is also theta. If you take one more angle, then this is also an angle theta. Likewise, all the points on the slope are making an angle theta with the positive x-axis. That means theta is constant. That means what? Theta is constant. If theta is constant, then tan theta is constant. Then tan theta is also constant. If tan theta is constant, then instantaneous velocity is also constant. The velocity of the object is constant. Velocity of the object is constant. Then we can say that the object the object moving with the object moving with uniform velocity. Uniform velocity. Are you able to see the board? Okay. So what is the meaning of velocity is constant? The object is moving with uniform velocity. What is the meaning of uniform velocity? The velocity of the object remains constant in equal intervals of time. Have a look. The object is moving from point A to point B. Okay, point A to point B. Uniform velocity means it is at a time t is equals to 0, t is equals to 1, t is equals to 2. So in equal intervals of time, velocity of the object is remains same, 2 meter per second, 2 meter per second, 2 meter per second. Are you getting? So this is called a uniform velocity. In equal intervals of time, the velocity of the object remains the same. Are you getting? So then it is called what? Uniform velocity. Are you getting? Okay. Okay, I'm going to analyze the third slope. Okay, what is the third slope they are given? And this is a x-axis. Along x-axis we are taken time, and this is y-axis. Along the y-axis we are taken displacement. Okay, so what is the third slope they are given? This is the third slope. Third slope is like this. La 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 la. This is the third slope. Okay. Okay, sir. So now we have to find an angle theta. Have a look. This slope is not a straight line like this. See, it is not a straight line. It is a curved slope. It is a curved slope. So to find an angle theta, we have to take the point on the slope. Just to draw the tangent from that point. So I am taking the point on the slope and I am just drawing the tangent from that point. Now we have to take an angle theta from the positive x-axis. Let us say this is an angle theta 1. I am taking the next point on the slope. To find an angle theta, we have to draw the tangent and next we have to consider an angle theta. Okay. Again, if you want to find the third angle on the slope, just take the point, draw the tangent, and from the positive x-axis, you have to take an angle theta. Have a look. The slope is like this. The slope is like this. So compare with this angle. This angle is a small. Again compare with this angle. This angle is small. Okay. So it is clear from the graph an angle theta is decreases. An angle theta is what? Decreases. Have a look. Compare with theta 1. Theta 2 is less. So theta 1 is greater than theta 2. Theta 2 is greater than theta 3 and so on. So that means what? Theta is decreasing with respect to the time. So with respect to the time, the angle theta is what? Decreasing. If theta is decreasing, theta is decreasing, then tan theta is also decreasing. Tan theta is also decreasing. If tan theta is decreasing, then instantaneous velocity or velocity of the object is decreasing. If the velocity of the object is decreasing, then we can say that the object is making non-uniform motion. The object is making non-uniform motion. Non-uniform means what? If I take a motion or velocity of an object like this, t is equals to 1, t is equals to 2, t is equals to 3 seconds, t is equals to 4 seconds. Okay. So from the graph it is clear that the instantaneous velocity of the object is decreasing. In between this interval of time, that means 1 second and 2 seconds. Let us say the instantaneous velocity of the object is 2 meters per second. Next, in this interval of time, t is equals to 2 and t is equals to 3. The velocity of the object, let us say 1.8 meter per second. 1.8 meter per second. And next, in this interval of time, t is equals to 3 and t is equals to 4. In this interval of time, so the velocity of the object is 1.6 meter per second. That means what? The velocity of the object is decreases with respect to the time. Therefore, then it is called what? Non-uniform velocity. In a given case, velocity of the object is decreases with respect to the time. Are you getting any doubts? Okay. So the next one, fourth one. Fourth one, they are given what? This graph. Okay, have a look. And this is the fourth graph they are given like this. Okay, right. How to find an angle theta? This is a not a straight line. It is a curved slope. Then what we have to take? We have to take points on the slope. Then just we have to draw the tangents from that points. We just draw the tangents. After drawing the tangent from positive x-axis, we have to take an angle theta. So theta 2, theta 3, and the theta 4. Have a look. Compare with theta 1. Theta 2 is more. Compare with theta 2. Theta 3 is more. Compare with theta 3. Theta 4 is more. That means what? Theta is increasing. Theta is what? Increasing. If theta is increasing, then tan theta is also increases. If tan theta increases, instantaneous velocity of the object is also increases. If the velocity of the object is increases, then we can say that the object is making uniform or non-uniform? Non-uniform motion. The object is making non-uniform motion. Are you getting? So it is clear from the slope. It is clear from the graph. So what is the graph says? With respect to time, the angle theta will be increases. If an angle theta is increases, then tan theta is also increases. If tan theta increases, instantaneous velocity is also increases. If the instantaneous velocity of the object is increases, that means with respect to the time, the velocity of the object is increasing. Then it is a non-uniform motion. Which motion it is? Non-uniform motion. Right. So pause the video and write the notes. Right. So let us see the fifth slope. Have a look. What is the fifth slope they are given? This is a time. This is a displacement. So the fifth slope is like this. Okay. I'm just taking this slope like this. Okay. I'm just taking the slope like this. So what we have to find? We have to find instantaneous velocity. To find the instantaneous velocity, we have to analyze an angle theta. Clear that an angle theta is greater than 90 degrees. Are you getting? Angle theta is greater than 90 degrees. If theta is greater than 90 degrees, then tan theta is negative. The tan theta is what? Just write like this. Tan theta is negative. If tan theta is negative, then the instantaneous velocity is also negative. Instantaneous velocity is also negative. But but it is constant. Instantaneous velocity is negative, but it is constant. Why? Because from the positive x-axis, every point on the slope is at a constant angle. Every point on the slope is at a constant angle. That means theta, 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 theta. All are what? Theta. Angle does not increasing, angle does not decreasing. But an angle theta is what? Constant. Although it is greater than 90 degrees. Angle theta is what? Constant. If angle theta is constant, then the velocity is also constant. If the velocity of the object is constant, then the object is makes uniform motion. Uniform motion. Is it here? Any doubts? I hope that you understood how to analyze the slope. So first to take a given slope and measure an angle theta from positive x-axis. In this graph, theta is equals to how much? 0 degrees, because given slope is parallel to positive x-axis. Theta is equals to 0, then tan theta is equals to 0. If tan theta is equals to 0, instantaneous velocity is 0. If instantaneous velocity is 0, that means the object is at a rest position. In this slope, angle theta is constant. Then slope is what? Constant. Then tan theta is constant. Tan theta constant. Instantaneous velocity is constant. If instantaneous velocity is constant, means the object is making uniform motion. In this graph, the theta is decreases with respect to the time. Then angle theta decreases, tan theta decreases, instantaneous velocity decreases. The object is making non-uniform motion. In this graph, fourth one, in the fourth one, an angle theta is increases with respect to the time, then instantaneous velocity is increases. If the instantaneous velocity is increases, then the object is making non-uniform motion. In a fifth one, theta is greater than 90 degrees. If theta is greater than 90 degrees, then tan theta is negative and the instantaneous velocity is also negative, but the object is making uniform motion because so each and every point on the slope is at an angle theta from positive x-axis. Is it clear? Any doubts? Let's pause the video and write the notes. 3, 2, 1, go. Right. So let us we discuss about acceleration. So what is the second one? Acceleration. Okay. So what is acceleration? Acceleration is nothing but what? dv by dt. The rate of change of velocity is called what? Acceleration. So what is the meaning of dv by dt? The rate of or the slope of graph of the slope of graph of v versus t. V versus t gives acceleration. Gives what? Acceleration. Are you getting me? So dv by dt means what? The slope of graph of v versus t gives what? Acceleration. Okay. So if we draw the graph for velocity versus time, then the slope gives what? Acceleration. Slope gives what? We draw the graph for velocity versus time, then the slope gives what? Acceleration. Are you getting me? Any doubts? Okay. So how to find the slope? We have the formula. Slope is equals to tan theta is equals to velocity divided by time is equals to what is this? Acceleration. What is this? This is an acceleration. So now let we have to find an angle theta. How to find an angle theta? From the positive x-axis, we have to take an angle theta in anti-clockwise direction up to slope. Then, so based on the angle, whether it is 0 or whether it is less than 90 degrees or greater than 90 degrees, okay. So, or the theta is equals to constant. So, based on that, we can find the what? Acceleration, whether it is a negative acceleration, positive acceleration, whatever it is. Are you getting? Right. So now what we have to do? Analyze the slopes. Analyze the slopes. How to analyze the slopes? Already we have discussed. Okay. So this is time along x-axis and velocity along y-axis. Okay. This is origin O. This is the first slope, slope number 1, and this is the second slope, third slope, fourth slope, and the fifth slope is like this. Okay, so this is what? This is the fifth slope. Are you getting? Okay, right. I'm taking the first slope. The slope is like this. This is time, this is velocity, and the slope is like this. So we have the formula. What is that? Slope is equals to tan theta is equals to, you can write velocity divided by time. It gives what? Acceleration. Now we have to find an angle theta. So with respect to this positive x-axis, the slope is parallel. With respect to this positive x-axis, the slope is parallel. Then angle theta is equals to how much? 0 degrees. If theta is equals to 0 degrees, then tan theta is equals to 0. Then acceleration is 0. Acceleration is how much? 0. What is the meaning of an acceleration is 0? Have a look. What is acceleration? The rate of change of velocity is called what? Acceleration. If velocity is constant, if velocity is constant, or if the velocity is uniform, if the velocity is what? Uniform velocity. That means with respect to the time, the velocity of the object does not changes. Then we can say that the velocity is what? Uniform or constant. So v is constant. If I write like this, d by dt of constant, because velocity is constant, then you will get acceleration is 0. Are you getting? Differentiation of constant is equals to 0. Now we got acceleration is equals to how much? 0. Acceleration is 0 means the velocity of the object is constant or uniform. The velocity of the object is constant or uniform velocity. Are you getting ma? So velocity of the object is what? Constant. So if the acceleration is 0, then velocity of the object is constant or uniform. Are you getting? Any doubts? Right. Let us see the second one. Okay. So what is the second slope they are given? This is the second slope. Let us take an angle theta from positive x-axis towards slope, where theta is what? Theta is constant. Theta is constant. Therefore, if theta is constant, then tan theta is also constant. If tan theta is constant, then acceleration is also constant. So acceleration is constant means the object is moving with uniform acceleration. The object is moving with uniform acceleration. In a given intervals of time, the acceleration of the object remains same. Are you getting? Right. So let us see the third one. So this is velocity and this is time. Now the graph is like this. So whenever the graph is like this, so the theta 1, let us say this is theta 2, and let us say this is theta 3. So theta 1 is greater than, theta 2 is greater than theta 3. Then angle can be decreases with respect to the points on the slope. Okay. So if theta is decreases, if theta is decreases, then tan theta is also decreases. Are you getting? Right. If tan theta decreases, then acceleration also decreases. Acceleration also decreases. So let us see the fourth one. So what is the fourth graph? The fourth graph is like this. This is what velocity and this is what time origin O. Okay. So at this case, the angles theta 1, theta 2 and the theta 3. So with respect to the points on the slope, the angle made by the positive x-axis are increases. Theta is what? Increases. Are you getting? Theta 3 is greater than theta 2 is greater than theta 1. So when theta is increases, if theta is increases, then tan theta is also increases. If tan theta increases, then acceleration is also increases. Acceleration is also increases. Are you getting any doubt? Right. So let us see the fifth one. Already we have discussed it now in a velocity concept. Okay. Right. What is the fifth one? This is the fifth one. So velocity versus time. This is origin. Wow. Right. Have a look. With respect to the positive x-axis, we have to take an angle theta towards the slope. Here theta is what? It is greater than 90 degrees. Whenever theta is greater than 90 degrees, then tan theta is what? Tan theta is what? Negative. Okay. If tan theta is negative, then acceleration is also negative. Acceleration is also negative. So if acceleration of the object is negative, then it is called a retardation. What is this? This is called a retardation or deceleration, also called as deceleration. If the acceleration is negative, then it is called what? Deceleration or retardation. So same thing that we are discussed in a velocity concept. Okay. So theta is equals to 0 constant, theta is decreasing, theta is increasing, and the theta is greater than 90 degrees. Okay. Right. So pause the video and write the notes. 3, 2, 1, go. Right. So let us see the note. What is the note? Have a look. Instantaneous velocity or velocity is nothing but what? Displacement by time. Right? So displacement what? S and the time is nothing but t. Right? S versus t. This means what? The slope of graph of S versus t gives what? Velocity. So if you draw the graph for displacement versus time, S versus t, then the slope, whatever the slope we are taken, this slope gives what? Velocity or instantaneous velocity. So from this equation, if I want to write the equation for displacement, so displacement is equals to, we can write velocity into time. Velocity into time. Are you getting? So displacement is equals to what? Velocity into time. Are you getting? What is its meaning? That means if we draw the graph for velocity versus time, if we draw the graph for velocity versus time, let I got the graph like this. I am just got the graph like this. Okay. Now displacement is equals to velocity into time means whatever the area covered by this graph, whatever the area covered by this graph gives displacement. Gives what? Displacement. Are you getting? Are you getting ma? So nothing is there. So velocity is nothing but what? Displacement by time. So that means S by T. S divided by T means what? The slope of graph of S versus T gives velocity. Now what is the displacement? Velocity into time. That means if we draw the graph for velocity versus time, then whatever the area covered by that graph, is gives what? Displacement. Are you getting? In a integration concept, I told you that. So whenever we got the equation like this, we can write a velocity is equals to ds by dt. Okay, so if you wanted to find the displacement, then ds is equals to, we can write v dt. So if you wanted to find the displacement, we have to integrate on either side. Integration means sum over all the areas, then we draw the graph like this. Okay, so if you want to find the area covered by graph, we are divided it into small strips. So this is dx, this is y1, y2, y3. Okay, then area covered by this graph we can write like this: v1 into dx plus y2 into dx plus, and so on. Can be written as summation over n is equals to 1 to infinity y1 into dx. This summation over can be represented by integration of y1 into dx, yn dx. So likewise we are discussed in an integration topic. Okay, so what is the integration gives? The area covered by the graph. Here, if you want to find the displacement, just we have to do integrate on either side. What is the integration of VDT? Integration of VDT means what? The area covered by velocity versus time graph. The area covered by velocity versus time graph gives and displacement. Are you getting? Right. So have a look. Note number two. Note number two. So what is acceleration? Acceleration is nothing but velocity divided by time. The rate of change of velocity is called the acceleration. Okay. And if we draw the graph for velocity versus time, graph for velocity versus time. So what is the meaning of dv by dt? The slope of graph of velocity versus time gives what? Acceleration. That means the slope covered by this graph gives what? Acceleration. Are you getting? This is what? Acceleration. I'm just writing acceleration is equals to dv by dt. And if you want to find the velocity, then dv is equals to, we can write a into dt. If you are integrate on either side, so now what is the integration of ADT? Integration of ADT means what? The area covered by ADT means what? Integration of ADT means what? The area covered by acceleration versus time graph. So gives what? Change in velocity. It gives what? Change in velocity. Are you getting? Are you getting any doubts? So the slope of graph of v versus t gives what? The slope, acceleration, and the area covered by acceleration versus time gives what? Change in velocity. This gives what? Velocity. Okay. Are you getting any doubts? Okay. Right. So pause the video and write the notes. 3, 2, 1, go. Note number 3. The following graphs does not exist. Why they are not exist? Have a look. Okay, the following graphs are not exist. Right. So I am taking the graphs like this. First graph, second graph, and third graph. Let us see velocity versus time, acceleration versus time, displacement versus time. Whatever it is, okay, acceleration time, velocity time, displacement time, whatever it is. Okay, so why they are not exist? Have a look. Let us say at this point the velocity of the object is v1 or v2, and at this point the velocity of the object is v1. Okay, right. Have a look on the timeline, or along the x-axis we have taken time. Right, have a look. At a time t1, the velocity of the object is v1. Also, at a time t1, the velocity of the object is v2. Have a look. v1, v2. That means at a given instant of time, the object does not exist on two velocities. The object does not have a two velocities at a given time. At a given single time, the object does not having the two velocities. Have a look. An object is moving like this. At a given time, at a time t is equals to 2 seconds, it does not have a two velocities. At a particular instant of time, the object has only one velocity. But in this graph, this object has a two velocities at a same time. At a same time, the object does not have two velocities. Is it clear? That's why this graph does not exist. Have a look. We have taken acceleration versus time. So at a particular instant of time, at a particular instant of time, let us say this is t1. No, at this point acceleration a1 and acceleration is a2. Okay, so at a given instant of time, the object has a two different accelerations. The object has a two different acceleration at a particular instant of time. It is not exist. It is not true. Okay, that's why this graph is not exist. If we come to this graph, so at a particular instant of time, t1, let us say t1, t2, t3, whatever it is. So at a given particular instant of time, this object has two different displacements. The object has two different displacements. It is impossible. It is what? Impossible. That's why this graph does not exist. Are you getting? Right. So next one, have a look. So if I draw the graph for distance versus time, distance versus time, and I got the graph like this, and I got the graph like this. And if I draw the graph for time and the speed, time and the speed, and at this time we got the graph like this. Okay, so these two graphs are also not exist. These two are also not exist. Why? Because the speed and acceleration, sorry, the speed and the distance, speed and the distance not having negative signs, does not having negative signs. Are you getting? Because speed and the distance never has a negative signs. Okay, this is time and this is velocity, and the graph is like this. Okay, or if we take a time versus acceleration, or if we take a displacement versus time. Okay, so these graphs are also not exist. These are also not exist. Why? Same, at a given instant of time, at a given instant of time, the object has two different velocities. The object has two different or four different, whatever it is, has different velocities at a given time. Okay, so a1, a1, s1, s2. Have a look. At a given instant of time, the object has different velocities. Here different velocities, different accelerations, and a different displacements. So these graphs are does not exist. So pause the video and write the notes. 3, 2, 1, go. Right. So my dear students, and just to bring up some example problems on a graphical section. Okay. So have a look how to solve the given graphs. So velocity versus time graph is given. What they are asking? They are asking to find the displacement. How to find the displacement? So in case of velocity versus time graph, the area covered by the slope gives what? Displacement. Have a look. This is what? Given slope. The area covered by the slope. Have a look. The area covered by, let us consider this is an origin O. Okay. So the area covered by the slope OA is what? So this is the area covered by the slope OA. Okay. Are you getting? Right. So have a look. Next, the area covered by AB slope. Have a look. This is the slope AB. Now the area covered by this AB slope is what? This one. Again, so the area covered by BC slope, have a look, this is the BC slope, and the area covered by this slope is what? This one. Are you getting? This is the area covered by BC slope. Next, CD. Again, the area covered by CD is what? This. What is the area gives? Displacement. Are you getting? Right. So area covered by the slope is equals to, have a look, from this slope, it is clear that this is shows what? It is a right angle triangle. Have a look, this is like a right angle triangle. What is the area of right angle triangle? Half into base into height plus, have a look, the area covered by the slope AB is what? It is like a rectangle. Then what is the area of rectangle? Length into breadth plus area covered by the slope BC. Have a look. So this is the area covered by the BC slope, but it is not a triangle, it is not a rectangle. It is the combination of triangle as well as rectangle. Have a look. If I draw the line like this, if I draw the line like this, here one triangle is formed and here one rectangle is formed. Now to find the total area covered by the BC slope, then it can be given by half into base into height of this triangle. Okay, so let us say this is a triangle O dash. Okay, half into base into height of the O dash triangle, and one rectangle is formed here plus the area of this rectangle, that is length into breadth plus, have a look, the area covered by the slope CD, again it is a right angle triangle, then its area is given by half into base into height. Are you getting? Right, which is equals to half into, in a first triangle. In a first triangle, what is the base? 0 to 2. 2 minus 0, how much? 2. Into height. What is the height of this triangle? Have a look. 10 is the height of the triangle. Plus, again, this rectangle. What is the length of this rectangle? Have a look. Again, 10 is the length of the rectangle. Into base. What is the base? 2 to 4. 4 minus 2, 2 plus half into, again, base of the triangle O dash, base of the triangle O dash, how much? 6 minus 4, 2 into height, height of this triangle, have a look, the height of this line is equals to how much? 20 minus 10, 20 minus 10 is how much? 10 plus, again about this rectangle, what is its length? 10 into its width, 6 minus 4, 2 plus, again this triangle area, half into base 8 minus 6, 2 into height of the triangle 0 to 20, height is how much? 20. Are you getting? Right. So which is equals to 2 to get cancelled out, 10 plus, here 10 to the 20 plus 2 to cancel out, 10 plus 10 to the 20 plus half of get cancel out into 20. So which is equals to 20 plus 20, 40 plus 10, 50, 70, 80. So 80 meters is the area covered by the graph. That is what? Displacement. This is what? Displacement. Are you getting? Any doubts? Just and find the area covered by these shapes. Okay, one triangle formed, one rectangle. In this graph, one triangle is there, one rectangle is there, and just divided these two, and we got what? 80 meter. After solving all the areas, we got the displacement is equals to how much? 80 meters. Is it clear? Any doubts? Easy one now? Right. Have a look. Again, second example is given. Okay. So they are asking, find the ratio of velocity of the object A to velocity of the object B. They are asking what? Find the ratio of VA to VB. Look, the graph is what? The graph is drawn in between displacement and the time. The graph is drawn between displacement and the time. Then the slope of the graph of displacement versus time gives what? Instantaneous velocity. So this is the first slope. Let us say capital A is the first slope. Then instantaneous velocity is equals to, how can we find the velocity? By using tan theta. So theta, how we can take theta? Always take theta from positive x-axis to the slope, where theta is equals to how much? Let us say this is theta A, which is equals to 30 degrees. So V instantaneous is equals to tan theta is equals to tan 30 degrees. What is the value of tan 30? Sin 30 value is how much? 1 by 2. Tan 30 value is how much? Cos 30 value is how much? Root 3 by 2. 2 to get cancelled out. You will get 1 by root 3. The value of tan 30 is how much? 1 by root 3. Are you getting? Right. So let us consider this is A. So the slope of graph of B instantaneous is again given by tan theta. So tan theta is equals to how much? Have a look. The second slope is at an angle theta B is equals to how much? 60 degrees. Always measure an angle theta from positive x-axis. How much it is? 60 degrees. Then tan 60. What is the value of tan 60? Root 3. What they are asking? Ratio of VA to VB. Just do like this. VA by VB, which is equals to VA value is how much? 1 by root 3. VB value is how much? Root 3. So if root 3 comes to numerator, it becomes root 3 into root 3, 1 by 3. So what is our answer? 1 by 3 is our answer. Okay. Are you getting? Any difficulties there? So the slope of graph of S versus T gives what? Instantaneous velocity. So instantaneous velocity is equals to what? Tan theta. Where how to find an angle theta? Always take an angle theta from positive x-axis. Here we got 30 degrees and here we got 60 degrees. So tan 30, tan 60. 1 by root 3, root 3. So they are asking the ratio. So VA by VB is equals to 1 by root 3 divided by root 3. If root 3 comes to numerator, it becomes what? 1 by 3. Okay. Right. Are you getting? Any doubts? Okay. Let us come to this question. Which of the following VT graph shows realistic situation for the body in motion? That means which of the following graph is exist? Which of the following graph is exist? Okay, na? So realistic situation means exist, existence of the graph. So which of the following graph shows velocity versus time graph? They are asking that. So let us see the first one. I told you that in a following graphs are does not exist concept. What I told you there, at a given particular instant of time, the object does not has a two different velocities or two different displacements or two different accelerations at a particular instant of time. If the graph is like that, that means it is a existence of two different velocities at a single time, at a particular time, then the graph is not considered. Okay, so have a look in a first graph. Have a look. I am taking the point here. Let us say at a time t1, this graph exists of two different velocities. Have a look. Two different velocities at a given particular instant of time. Let us say this is v1, this is v2. Have a look. At a particular instant of time, any object has a two different velocities? No, no, no. So that's why this graph is not a true. That graph is not a true. So if you comes to here, so I am taking the points on the graph. Have a look. All the points are exist at a different time. All the points on the graph are exist at different intervals of time. Then this graph is exist. Are you getting? Right. So if you comes to this graph, at a particular instant of time, at a particular instant of time, this graph has a two different velocities. At a particular instant of time, this graph has a two different velocities. It is not possible. In a single time, in a particular instant of time, there is no two velocities for the object. So this graph is also not exist. So comes to this. So at this time, it has a different velocity. It is also different velocity. But so if you comes to here, at a given particular instant of time, this object has two different velocities. Are you getting? At the same time, this object has two different velocities. Then this graph is also not exist. So our answer is what? B. B is our answer. Okay. Right. Comes to this question. Example number 4. Okay. So what is the example? Acceleration versus time graph is given. So they are given this graph, acceleration versus time. Which of the following graph is true for velocity? Which of the graph is true for velocity? I told you that area covered by acceleration versus time graph gives what? Change in velocity. Is it clear? Right. So let us see the slope. So this slope is what? This is parallel to positive x-axis. This slope is what? Parallel to positive x-axis. Then angle theta is equals to how much? 0 degrees. So if angle theta is equals to 0, then tan theta is equals to 0. If tan theta is equals to 0, then the acceleration is equals to 0. If the acceleration of the object is equals to 0, then the object has constant velocity. Then the object has constant velocity. So for this slope, in a given options, we have to check which graph is having constant velocity. Which graph is having constant velocity, we have to check. So have a look. In a first graph, the slope is moving like this. That means the angle made by the slope with positive x-axis remains same. If theta same, then tan theta remains same. If tan theta remains same, then the velocity of the object is constant. So maybe this is a one of the answer. Have a look. The slope is like this. It is decreasing, and the slope is greater than 90 degrees. Here theta is greater than 90 degrees. Then the velocity is negative. But what we need? Constant velocity. So this is not a correct option. Okay. So if you comes to here, this one and this one same. Maybe this is the answer. Maybe this one is answer. So here also the slope is negative because theta is greater than 90 degrees. Right. So in these two, one is correct answer. Then we have to find it. So if you comes to here, in this part, the area covered by acceleration versus time graph, the area covered by this slope, the area covered by this slope is equals to how much? 0. Area covered by, so this is what, not an acceleration. The area covered by AT graph is equals to 0. Area covered by acceleration versus time graph is equals to 0. Then the velocity of the object is 0. Why the velocity of the object is 0? The area covered by AT graph, the area covered by the slope of graph of AT gives what? So this means what? This area gives velocity, change in velocity. Is there any area exist? Is any area is exist? No area exists because the slope of graph of A versus T on the surface of the x-axis. Then any area exists? No area. Area is equals to how much? 0. If area is equals to 0, then velocity of the object is 0. Have a look. Here, the velocity and angle theta is parallel to positive x-axis, then theta is equals to 0. If theta 0, then tan theta is equals to 0. If tan theta is equals to 0, velocity of the object is 0. This is correct. And this is also correct. Have a look. These two are same. Maybe this is also an answer. Maybe. Next, have a look. Again, the acceleration of the object is parallel to positive x-axis. Parallel to positive x-axis. Then theta is equals to 0. If theta 0, then tan theta is equals to 0. Tan theta is equals to 0. Then acceleration is 0. The acceleration 0. Velocity of the object is constant. Have a look. Here in a given graph, again the slope is decreased and theta is greater than 90 degrees. So this is not an answer. So if you comes to here, the velocity of the object remains constant, then the option C is correct. Then the option C is correct. So likewise, you have to solve the graphs problems. Okay. Any doubts? Right. Pause the video and write the notes. 3, 2, 1, go. So this is the end of the today's session. We will meet on a next session with a fresh concept and important concept, that is equations of motion. Okay. I hope that you understood this concept, how to find the area covered by the graphs and how to analyze the given graphs. Okay. All these things. Right. So my name is Rakesh Kanaganti, signing off. Jai Hind.